Hello and welcome to today's lesson. We're going to be looking at simplifying radical expressions, which means we're going to be looking at problems that have square roots and cube roots in them, and then constants and variables, and simplifying them down to their smallest, simplest form. So that means you're going to have a strong understanding of what it means to take a square root and a cube root, and then also you need to have a strong understanding of absolute value. So if you're struggling with any of these problems, I would recommend going back and reviewing those concepts. So as always, make sure that you're taking notes as you go through these videos. It's going to help you make the most of your time. If I ever go too fast, just pause the video and rewind and get caught back up. You want to make sure to copy down the vocabulary words and some examples, and you can even pause at the beginning of an example. You try the problem without my help, and then go through and watch the video to see what you did right and what you did wrong so that you can get a gauge of what you need to study and what you know really well. So I'm so glad that you are joining us today, and let's go ahead and take some notes.
Being familiar with the perfect square numbers and the perfect cube numbers can really help you out. So you might want to pause this and either take a picture or a screenshot to put in your electronic notes or copy it down in your notebook so that you know that when you square these numbers, you're going to get these numbers. And then also you need to realize that it works the other way around. If you take a perfect square and take the square root of it, you're going to get back to that original number. So here's the square numbers through 30, and then here's the cube numbers through 12. And just being familiar with which ones these are will just make these problems go faster. But the more practice that you do, the more familiar you're going to get with these questions and numbers, and it's going to make it easier and faster for you. And you can always use your calculator to double check if you're not 100% sure. In order to read the questions and know what the problem is talking about, knowing the different parts of a radical can be helpful. And a radical is this entire problem here with the square root and the numbers. This entire thing is called a radical. This square root symbol, or cube root symbol, is called a radical symbol. The number underneath the radical symbol is the radicand. And the number that's little here in the little corner is the index. If the index is empty, you assume it's a 2, that it's a square root. In Algebra 1, we're only going to be looking at numbers that have an index of 2, so the invisible one, or 3, so cube root. These are the steps for simplifying radicals. I will be going through these steps and showing you actually examples of them when we do in these problems. So for right now, go ahead and pause this and make sure that you have these in your notes. But step 1 is write the prime factorization of your radicand, so it's underneath the radical symbol. Look at the index of the radical. If the index is 2, circle groups of 2 identical numbers of variables. If the index is 3, circle 3 groups of 3 identical numbers of variables, and so on. The number or variable from each circled group will show up outside the radical symbol one time. That's important, one time. Anything left uncircled will remain under the radical. If everything under the radical symbol is circled, the radical symbol will disappear. And then you multiply the numbers and variables outside the radical together to get your final answer. There's one special case that you need to watch out for when you're solving these problems, and that special case is the even-odd rule. So if a real variable to an even exponent is under a radical with an even index, when the radical is eliminated, the resulting exponent or variable is odd, then the absolute value signs must be placed around the variable. So let's look at an example of what this means and why it works this way. So if I have the square root of x squared, I have an even index, an even exponent under the radical. And when this is simplified, the square root and the square undo each other, and I'm just left with an x. And that's an invisible 1 there as the exponent, so that's odd. So I have even, odd. And so that means that my final answer here is going to have absolute value marks around it. And the reason for that is, let's go ahead and test some points. So I substitute an x equals 3 here. I'm going to square that 3 first, which is 9. So I'm going to have the square root of 9. And the square root of 9 is 3. And so, simplified, my answer is 3. And then here, my answer is this absolute value of 3, because that's what my x is. So they match. Now let's look at if x is equal to negative 3. So if I substitute negative 3 into the original problem, I get the square root of negative 3 squared. Negative 3 squared is 9. The square root of 9 is 3. So here, if I didn't have those absolute value symbols, it would just be x. However, I started off this problem with x being negative 3. And my answer here is positive 3, which is not x. But if I put those absolute value symbols around it, if I put them back, then the absolute value of negative 3, the x value that I'm testing, is positive 3, which matches. So that's why you have to have, when you have an even variable, an even index, and an odd exponent in your answer, that's why you have to include the absolute value symbol. So that's the special case that you need to watch out for and remember when you're solving these problems. Example number 1. You're going to simplify the algebraic expression below. So here, this one's pretty simple. I just have one variable, no numbers, no second variables, under the square root, x. So that means the prime factorization of x to the 18th power is going to be x times itself 18 times. So I'm going to go ahead and write that out. And so once you have that done, that's just what it's going to look like. And then the second step is to look at the index. And my index is blank, so that means it's going to be a little 2. And since my index is 2, I'm going to start to circle groups of 2. Identical groups. That means I'm going to circle x's with x's. So I'm going to go ahead and circle groups of 2. And then step 4 says the number or variable from each circled group will show up outside of the radical symbol one time. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 groups. So that means I'm going to put 9 x's outside of the radical symbol. And since I have nothing left under the radical symbol, then the radical symbol is going to disappear. And then I just need to multiply everything outside of this square root together. So here I have x times itself 9 times. That's going to be x to the 9th. And I'm done with that problem. Except that special case I said not to forget about, even, odd. I need to check. So here I have an even exponent under this square root, an even index because it's a square root, and then the exponent in my answer on that variable is odd. So even, odd. That means I need to put absolute value symbols around my answer. And so I go up here to my choices, and A is going to be my final answer. Whether you put the exponent inside of the absolute value or outside, it doesn't matter. Both are equivalent no matter what. So either way of writing your answer is acceptable, and so that's why A has both. This next problem, I have one variable like before, but now I have a number. So to do the prime factorization of a number, I'm going to use a factor tree. So I'm going to think, what divides into 49? 7 divides into 49. 7 times 7. And 7 is a prime number, so I can't break that down anymore. So that means the prime factorization of 49 is going to be 7 times 7. So I'm going to write 7 times 7. And then x to the 10th is x times itself 10 times. So I'm going to write x 10 times. And now I'm going to circle pairs. So 7 and 7 is a pair. X and x is a pair. Another set of x's, another set of x's, another set of x's, and another set of x's. So once again, I've circled everything under the radical symbol. That's just going to drop out of my answer now. And so I'm going to write each pair once outside of the radical symbol. So that's going to be 7 with 5 x's. And now I just multiply everything together that I can think of. So 7 has nothing to multiply with. And then x 5 times is same as x to the 5th power. And so now I'm done. I just need to check for that even, odd rule. So I have an even index of 2. On the x variable, I have an even exponent. And on the x in my answer, I have an odd exponent. So that's even, odd. That means around my x, I'm going to need to have absolute value symbols. So once again, whether that variable has the exponent inside or outside the absolute value symbols, they're both the same. So that means A here is going to be my final answer. So this next problem, I'm going to follow the same steps. I'm going to write the prime factorization of 50. And so 50, I know that's divisible by 2. 2 times 25. 2 is prime, so I can't break that down anymore, but 25, I can break that down into 5 times 5. And 5 is both prime, so that means the prime factorization of 50 is going to be 2 times 5 times 5. And then I still have that x to the 5th. And I'm not going to write that as x times itself 5 times, because I want to show you a little bit of a shortcut way of doing those steps, because once you get into numbers that have very large exponents, writing out x to the 40th, you can miscount and make a mistake. So I'm going to show you another way so that you can use that way with bigger numbers, and then you can pick which way you're more likely to get the right answer with. So whichever way you're the most comfortable with. So I'm still going to do the prime factorization with the numbers though. So I'm going to circle the 5s because they're a pair. And that means I'm going to have 1 5 that comes out of the square root. And this time I'm going to have that 2 stay underneath the square root. And then I'm going to look at my x to the 5th. I have an invisible index of 2 on this square root. If I think about 2 divides into 5 how many times? 2 divides into 5 2 times with 1 remaining. So that means I can pull out 2 x's. So x squared with 1 remaining underneath the square root. So once again, 2 divides into 5 2 times. That's where this x squared comes from. With 1 remaining. So I have 1 x remaining underneath the square root. And now I need to just check for the even rule. Even odd rule. So here I have an even index, but the x has an odd exponent. So I don't need the even odd rule doesn't apply here because of that odd exponent in the question. So I'm done. This is my final answer, which is choice A. Here's another radical I'm going to simplify. And you can see here, writing out 37x's, y's, and z's would take a lot of paper, and also you could, if you forgot one, it would mess up your whole answer. So that's where using that shortcut I taught you in number 3 can be useful. But I'm still going to find the prime factorization of 180. So I see that ends in a 0, so that means I can multiply something times 10 to get to 180. So 18 times 10 gets me to 180. 18, I know, is 2 times 9. And then 2 is prime, so I can't break that down anymore, but 9 is 3 times 3. Now 10, that's going to be 2 times 5, and those are all of my prime numbers. So that means that 180 can be rewritten as 2 times 3 times 3 times 2 times 5, and then I still have my variables. So I'm going to have x to the 37th power, y to the 37th power, and z to the 37th power. So now I'm going to go through and circle my pairs. I have 2's here that match, and I have 3's that match. So that means outside of my radical, I'm going to write 1, 2, and 1, 3. And the 5 is going to stay underneath the radical. And now I have that invisible index of 2. So I'm going to think about 2 divides into 37 how many times? It divides into 37 18 times. So I'm going to write an x to the 18th outside of the square root with 1 remaining. And so that's going to be 1x remaining underneath. And I do the same thing with the y's. 2 divides into 37 on the y 18 times also. So I'm going to have y to the 18th with 1 remaining. So I'm going to have 1y remaining underneath the radical. And then I'm going to do the same with the 37 on the z. So I'm going to have z to the 18th and 1z remaining underneath. And then my last step is just to multiply these numbers outside of the radical together. So that's 2 times 3 is 6. So my final answer is 6 times x to the 18th power times y to the 18th power times z to the 18th power, and then the square root of 5xyz, which is going to be choice B. Here's another example. This time I have a number already outside of the square root. So I'll show you how to work that into your answer. So I'm going to break down 9. 9 is 3 times 3. And so that's going to be a pair. So that means I'm going to move a 3 outside of the square root, and I don't have any numbers left for underneath the square root. So that's going to look like 9 times 3 outside of the square root. And then I'm going to look at my x to the 12th power. I have an index of 2. So 2 divides into 12 6 times. So I'm going to have x to the 6 with no remainder. So I don't have anything underneath the square root. So it's just going to fall off in my answer. I don't really need it. I'm going to multiply these two numbers out front together. 9 times 3 is 27. And then I have x to the 6th. And then I just need to check to see if we have the even, odd rule. So I look at my first variable, which is x. And I have an even index, an even exponent on the x. But I have an even exponent on the x in my answer. So that's even, even. No absolute value symbol is necessary. So that means choice C is going to be my final answer. Now I'm going to look at some examples with a cube root. So my index here is now a 3, and it's written right here, so that's how I know. So I'm going to follow the same steps, but only instead of circling pairs in my prime factorization, I'm going to be circling groups of 3. So I'm going to look at 125. 125 ends with a 5, so I know I can multiply 5 times something to get 125. 5 times 25, 5 quarters gets us to 125. And then I can further break down 25 into 5 times 5. So there, I have a group of 3 in my prime factorization of 125, which means I can move a 5 outside of the cubed root. And I don't have any numbers not circled, so I don't have anything to place underneath the cube root. So now I'm going to look at the exponents on my variables to see how I'm going to split those up in my answer. So I'm going to look at this time, how many times does 3, the index, divide into 36, the exponent on the x variable? So 3 divides into 36 12 times, so x to the 12th power with no remaining. So I don't have any x's underneath the square root. And next I'm going to look at how many times does 3 divide into 25? Well, it divides in 8 times, so I'm going to have y to the 8th power with 1 remaining. So I'm going to write y to the 8th out front and a 1y underneath the radical. Then I'm going to do that one last time with the 38th exponent with the z's. So 3 divides into 38 12 times. So I'm going to have z to the 12th outside of the radical with a remainder of 2. So I'm going to have z to the squared underneath the radical. And because my index here isn't even, cube roots you don't have to do the even, odd rule with because it has an odd index, not an even index, so I don't have to check that. I don't have any numbers to multiply together outside, so this is going to be my final answer, which is choice D.